just like we have our sine, cosine, and tangent, okay, we had our inverse sine and inverse cosine and inverse tangent. When do we use the inverses? When you're finding the angles. So it's very important that we still can declare the difference between those two. Regular trig functions are always going to be when you're finding a missing side. Okay. Inverse trig is when you are solving for the angle. Okay. So now we have angles of depression and angles of elevation. Okay. An angle of depression is the angle that is below the horizontal that an observer must look to see an object that is lower than the observer. So say I'm in a hot air balloon up here and I'm looking at money on the ground. Okay, my angle of depression is going to be the angle that I have to look at in order to see the object. Okay, the way that you can help distinguish between depression and elevation is usually when you're depressed, you're feeling down. Okay. So your angle of elevation or your angle of depression is always going to be the one that's going down. Okay. An important thing to distinguish also is that if you were to make these right triangles, okay, your angle of depression is always going to be an upside down right triangle. Okay. It is not this angle. Okay. This is not an angle of depression. Okay. Your right triangle needs to be upside down. Okay. On the contrary, you have the angle of elevation, and the angle of elevation is the angle that is above the horizontal. And that's just looking up at something. So if I'm on the ground and I'm looking up at the hot air balloon, or I'm on the ground looking up at the airplane, or whatever it may be. Okay, and again, if you draw your right triangle, your right angle, your angle of elevation should all be along the horizontal. Okay, so if this is your horizontal, you're above it. If this is my horizontal right here, it's the angle that is below. Alright. So if I'm on this picture, I've drawn now the two right triangles. Okay, I have my angle of depression right triangle, and then this angle right here would be an angle of elevation if the object was looking at the observer. Okay, so if this was my horizontal for my angle of elevation, this is my horizontal for my angle of depression. Okay, what do I know about these two horizontal lines? They're parallel. Okay, so then what would I call this angle of depression and this angle of elevation? What do we call these two angles? Alternate interior angles. So this angle of depression and the angle of elevation should be what? Congruent. Okay, so your angles of elevation can come from this way or they can come from this way, but the angle and your right angle are along the horizontals. Okay, then your angles of depression are upside down. If this is your horizontal, that's your angle of depression, or it could also go the other way. Okay, let's look at two examples. Raymond is standing in Paris looking up at the Eiffel Tower with a 40-degree angle of elevation. He is 386.12 meters from the tower. How tall is the Eiffel Tower? Okay, here's Raymond. I know this is not what the Eiffel Tower looks like, but I'm just drawing a tower. Okay, what's my angle of elevation? 40 degrees. Here's my horizontal. What other measurement do I know? How far he is from the tower, so where is that going? the horizontal, so 386.12 meters. And then what am I looking for? The height. So is that going opposite or hypotenuse? Opposite, so that would just be x. Okay, so I have an angle. I have two measurements here. Am I using inverse sine sorry, not inverse sine. Am I using inverse trig or am I just using my trig functions? Trig functions, okay. X represents what side? Opposite. 386.12 represents which side? Adjacent. Okay. So when you have opposite and adjacent, what happens? Tangent. So you have tangent of 40 equals what? X over 386.12. And then how am I going to get x by itself? Multiply both sides by 386.12. So those cancel, and I'm left with x equals 386.12 tan 40. You need to make sure your calculator's what?
On the
degree mode, so make sure it's in degree mode. Let's round to the nearest hundredth. What do we get?
343 into hundredths, 99.
99 what? Meters. Okay, so that is just your basic angle of elevation problem. Okay. Had they given you the height of the Eiffel Tower and the distance away from the tower and asked you to find the angle of elevation, what would you have had to do? Inverse trig. Okay, so all these problems work both ways. Okay, so make sure you know how to solve them, whether it's asking for a length or the angle. Alright, number 2. A blimp is flying to cover a football game. The pilot sights the stadium at a 7-degree angle of depression. The blimp is flying altitude of 400 meters. What is the horizontal distance in meters between the blimp and the stadium? So we have a 7-degree angle of depression, an altitude of 400, and we want to know the horizontal distance. Alright, so here's my blimp. Here's my Cowboys, or whatever, my football game. What kind of right triangle do I need to draw? Right side up or upside down? Upside down. Okay, is my angle going at the top or the bottom? The top, 7 degrees. Where's 400 meters going? Adjacent or opposite? Opposite. Where's x going? Hypotenuse or opposite? Or sorry, hypotenuse or adjacent? Why adjacent? Because it's asking you the horizontal distance. So this is where you guys are going to make mistakes, okay, if you don't read the word problem appropriately. Okay, it's not going to be in the math. It's going to be solving for the wrong thing or setting it up wrong. Okay, so it asks for the horizontal distance. Okay, so 400 represents which side? Opposite. X represents adjacent. So what kind of trig function do I have? What kind of trig function do I have? Tangent. So I have tangent 7 equals what? 400 over x. How am I going to get x alone? Multiply both sides by x. And then you're going to have x tan 7 equals 400. Now what? Divide by tangent 7. And to the nearest hundredth, let me know what you get for x. Alright, what does x equal? $3,257 point what? 74 what? Meters. Don't forget your units. Okay, so there are 5 questions left. There are 5 tables of you guys. So you're gonna have 15 minutes with your table to work through the 5 questions. Okay, I'm gonna assign 1 table each question. So you guys have question 3. Matthew's table has question 4. Garrett, you guys have 5. TJ, you guys have 6. And this front table will have 7. Okay, so at the end of the 15 minutes, you guys are going to send one person up here to teach the class about your problem. But you need to work through every problem. But you want to master the one that you're obviously going to come up here and teach. Okay, if you have questions along the way, ask. And I will come by and check your answers if you want. Okay? But work together as a table. Go.